In this SpongeBob-inspired video, you guys are going to be taking notes on 2-2 and 2-3, proving theorems. I'm going to get to this section at the very end. I want to help you set up your notes first. In your notes section, on that page where you normally take notes, I'd like you to cut it in half. But our notes aren't lengthy today, but they're going to take up a lot of space. So on the page behind that, I'd like you to also cut that in half. So in the front of your notes and the back of your notes page, you're going to be calling that section A, B, C, and D. If you're watching this video, it's because we're assigned section C. Note that this last page should remain blank. Now, I'd like you to recall that a theorem is a statement that has been proven using postulates, definitions, and other theorems. Now, everyone else in your group is going to be getting this quick information about theorems and two-column proofs and paragraph proofs. You don't have to take notes on it, but you can if you want to. And I want to give you a quick kind of informational tour of what a proof is. So the first thing I want to show you is that there are a couple different types of two-column proofs. And it all starts with the most important part, which is a thought process. So suppose you're given a problem. Prove that if two diagonals in a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Now, I don't want you to fret about this. Just imagine that there's a given information and they want us to prove something. The first thing you would do is think about it. You look at the picture, you think about what it means, what's given, what theorems and definitions you have. Now, one option for proving a proof is writing it in a paragraph. So here, the author wrote all of his or her thought processes in an organized fashion, a logical fashion, to prove that the quadrilateral is a parallelogram. Now, the most common proof that we're going to be utilizing a lot is this one. It's called the two-column proof. Now, the two-column proof has a section over here. Here they wrote argument. We're going to call it statements. And on the right-hand side is the reasons, the reasoning why. Over here is where you're doing your math. You're showing your logical steps from A to B, from 1 to 10. It always begins with what's given and ends with what you wanted to prove. And on the right-hand side, it's the reason. It's the justification behind what you said. And that's what you're going to be seeing today, is a lot of two-column proofs, and you're going to be helping me fill in the reason why and the argument. The first information that you're going to be bringing back is a theorem, theorem 2-2. And recall that you don't have to memorize that this is theorem 2-2. I just want you to know that so you can find it in your book. This one does have a title. It's the angle bisector theorem, and here's how it goes. If ray bx is the angle bisector of angle ABC, so if this is the angle bisector of ABC, then the measure of angle 1, this angle, is half of the full angle, and the measure of angle 2 is half of the full angle. That's it. Now I can prove the angle bisector theorem to you if I take the hypothesis and conclusion, and then I can set up a two-column proof using this diagram to help me, and that's what we're going to be doing today. So there's some gaps here. We're going to be using this kind of word bank at the bottom to fill in our two-column proof so that I can prove to you without a doubt that the angle bisector theorem is true. Now what's first missing is the given information, and that was the hypothesis of our theorem, which was Bx is the bisector of ABC, and that's ray Bx, so make sure you have your ray up there. And the first part of a two-column proof is the easiest. It's the given information. That's what we just put in. So I'm going to go ahead and put that in there too, and again, don't forget that arrow there. Okay, so if Bx is the bisector of ABC, what's our next logical thought? Well, what's already written in here is that the measure of angle 1 is equal to the measure of angle 2. And I know that because I know what a bisector is. I get that from the definition of an angle bisector. That's not too hard. Okay, well, let's see if we can follow their logic. Then they say the measure of angle 1 plus the measure of angle 2 is the full angle. The measure of angle 1 plus the measure of angle 2 is the full angle. Now that's just angles adding together. That's the angle addition postulate. All right, not so hard. All right, the next one requires a little bit of brain power here. I'm going to go ahead and give you the reason. The reason is going to be the substitution property, and let's see if you can figure out how I'm going to use the substitution property. I'm going to take this equation here, and I'm going to substitute in something that's equal to the measure of angle 2. Well, I know that the measure of angle 1 is equal to the measure of angle 2. If that's true, then I can say, let me make this a little bit bigger. Then I can say that here's our measure of angle 1 and the measure of angle ABC. Instead of the measure of angle 2, I'm going to put in an equivalent value. That's the measure of angle 1. That's how I substituted it in. Now, from algebra, you know that one quantity plus the same quantity is 2 of those quantities. So that's not too hard. 2 of those angles, all right? That's not so hard. We got that by combining like terms. Measure of angle 1 plus the measure of angle 1, that's 2 measures of angle 1. And I know that's a lot of symbols, but hang with me here. Now, if I want to get the measure of angle 1 by itself, and that 2 is multiplying with this quantity, then I'll have to do the opposite of multiplying. I should divide on both sides, right? If I divide on both sides, then that's the division property of equality. It's because I'm preserving equality by dividing on both sides. Now, this makes me happy because I end up with part of my prove. Here it is right here. I want to prove that the measure of angle 1 is half of the measure of angle ABC. But how do I prove that the measure of angle 2 is half of the measure of angle ABC? How do I do that? Well, I'm going to use substitution again. I know that the measure of angle 1 is the same as the measure of angle 2, so I'm going to take this and pull it here. I'm going to substitute it in. And now I have proven that if ray BX is the bisector of ABC, then angle 1 is half of the full angle, and angle 2 is half of the full angle.